have your permit for a moped.
Do they have a driver's license
Maybe
yet?
he doesn't have. Maybe he don't drive.
I was just
Are you guys looking at me?
Patio.
One. The first one is number 2.
Ryan Woody to the office, please. Ryan Woody to the district office.
What?
Shoot, did we need to wrap it?
Yeah.
What did you do? No, in.
What else did you do, Tommy?
Yeah, but I did it a lot worse than that. And he saw me, he's like, I'm really uncomfortable. I know, I'm sorry.
What's up, man?
Jack, did you see me do that?
No, I saw you hiding your face, and I was like, what are you doing? Why would you do?
I just like went like this.
So you're going to Bryce's tonight?
Bad timing, you know?
You doing anything after school?
Yeah, he's leaving with me.
Go home. Why? Your mom.
He had plans all week.
What's the thing, man? I saw that.
Oh, good.
But I didn't have to show your graphics.
I saw a video. It's like,
You sent that picture?
sorry,
Yeah, I didn't do the graphics.
My grandpa, I'm not even, he's a wizard. So, I love you,
He says
man.
we're having a roll up.
Are you hair goes on the head. Bro!
I don't got anything.
Wait, Zach, no.
Like,
It's
more
not-
around
it
the
doesn't
street,
really- it doesn't really have to do that.
more in the green pasture.
Yeah, if there was no sun,
We always have it.
It is.
I never hear
I
no.
don't even know how.
Ew.
I mean, I can try. It's not like.
He has been trying to this evening.
That's my fighting stance.
You know what?
Oh, you missed.
You did when he's coming at us now.
I go up, I go sideways. Pretty cool.
Guys, I have nothing to send you.
Hey, we have homework due today, page 172.
I have
Hopefully
nothing
you
to
picked
send
up graph paper. I kind of warned you earlier this week that you had to stop acting and get graph paper.
right now.
Yeah, I lost that graph.
Why not?
I'm screwing my graph.
Just put it on the website so you can
You know I can't have that.
We don't have ink in our home.
Yep, and
After
then
our salt call, this
approximately.
goes
Ink in our home.
We can't stop that.
What? You
That's what happens when the media summer break. Printer hooked up to it.
What?
We don't have ink at our home.
George, do you ever do
That is just something we don't have.
Okay.
We don't have ink at our home.
Hey, let's take a seat. Quick, I'm getting by.
Oh, did they really?
I'm crying on the
When you burn your
Sorry,
you're like,
got
wow,
my
that's
candy.
really freaking
What?
You got candy.
All right, hey, here we go.
weird.
Okay, today I'm gonna fly through a quick review here. I'm gonna have you try a couple problems out, see kind of where you're sitting, see how well you kind of know the stuff that I did not get to go over with you. It was Miss Stephens, so thank you very much
I
for
like
that.
your note taking better.
I don't worry.
On the there on the back. All right, so,
She's in the back.
all right.
I know she is.
All right. All right. Hey, let's talk about some of these forms. You should be somewhat comfortable, with Slope-Intercept Form, Standard, and now General. I don't know if General is one that you've seen before, but at least you've seen it now. Let's do a quick review of those to make sure that you see every aspect of what I want you to be able to do. Okay. So let's talk about Slope-Intercept Form first. start with this one. We'll kind of work our way to the other ones. Now, anyone remember what the formula is for this one, this style? Good. Yep. All right, good. So this is like, this problem right now, this formula is the go-to formula that they typically use in Algebra 1, maybe Algebra 2, maybe in certain cases, but its major use is graphing. It's just really easy to graph these because the way that this is actually set up, so the major use of this is just graphing. Going from this equation to a graph, not the other way around, okay? So it's actually graphing the equation. So why it's so important is that the m here, this is your slope. Now slope, if you don't know, is rise over run. How far your graph is going up to the right or down to the right. That type of thing. That's how slope works. I'll write that down on the board in a minute. The b here is your y-intercept. It's a big fancy word for saying where does it cross the y-axis. The problem with that is sometimes when you look at the picture, it may not show that. So that's the difference. So that's why if you have the formula, it's easy to start the picture. If you have this, you just go right for this spot, put a dot, and then use your slope to go from there. But that's why we actually use it for graphing. So, but let's talk about the slope idea, because you do need to know how the slope works, other than y-intercepts. We've kind of done those before. Slope, you know, it's the little letter n that you see in this formula for sure. But the actual formula that you should know is this. I'll explain what this little symbol is. Yeah, it's delta. It means change in. Right? That's like the Greek definition of delta. The changes in y's or the changes in x's. Well, it's a big fancy way of writing this. Changes in y's, changes in x's. Now the little 1's and 2's, it just means that they're different variables, right? It's the second y number to the first y number. The second x number to the first x number. It really doesn't matter. If you want to erase those 1's and 2's, it's the same thing. You subtract the x, the y's, you subtract the x's. You have to put the y's on top. This is the rise of your graph. How far it's going up on the y-axis or down the y-axis versus how far it's running, rise over run. That's kind of the idea. Okay, questions with slope. Now, if your graph goes up to the right, so it's going up to the right, that's positive slope. The reason why is that both numbers have to be positive. Because that's just how it works. It goes up if the top number is positive, and it goes to the left if we're going like negative numbers to run. But up to the right is positives for both. So that's just something. Do we understand positive slope? Do you know how it would look if you were to graph it? Up to the right. Negative slope, very opposite. You're going down to the right. So the top number is negative. Down and then going to the right. That's just how I would think. Okay, these are the two go-to. Like most people know them. They can look at a graph and oh, it's negative slope, it's positive slope. These two are the big deal for how you know is your problem increasing or decreasing. That's what I always refer to. Like, does your picture look like this? Is it going up to the right? That's increasing the entire time over the life of that problem. Versus decreasing would be a negative slope. Like that. Going down, that's a decreasing problem. Even though there's arrows, it's still decreasing. Okay, questions on slope for right now. Now there's two other types of slope. There's zero slope, which is, if you don't know, zero slope is when you've hit like a bar where it's going straight horizontal. How that works is the top number of your slope is literally the number 0. You're not rising. It's literally just a flat line. So 0 is not rising or falling, but it's just running a number. And it doesn't matter if this number is positive or negative, because anything you take 0 divided by number, it literally gives you the number 0. That's why they call it zero slope. As opposed to the other slope, which I heard somebody refer to as undefined slope. Undefined slope. Or what I've heard to in other textbooks is referred to as no slope. There's just no value for slope. The reason why is because when you graph it, but on no slope, it's just going up and down. Now the reason why they call it undefined is because the top number, whatever it is, let's say it's 7, you're rising, right? It's going up 7, right? But it's never running. It's never going to the right or left. There's no positive or negative number on the bottom. And why they call it undefined is that this fraction doesn't exist. You can't divide by 0. You can't have some number of something divided into 0 parts. It doesn't make any sense. It's got to be at least the smallest number of 1 part at least. All right. Any questions with the slopes? Now, why that's important, why I want you to know that, and why you probably worked on that yesterday, is because when you have this formula, when you have this equation, you can take and graph it like instantly. Because it's a no-brainer. Like, oh, this is how you graph it. You know, you start with the y-intercept and you go up this number over this number, that type of thing. And it's just super easy to look at that. So let's take let's actually pop up a graph here so you can see that. So I'll just leave it right here for right now. So if I gave you half x minus 6, this is slope-intercept form. Your y-intercept number is the negative 6. So that means on the y-axis, find negative 6. 1, 2, 3, 4, 5, 6. There's where your first dot goes, first coordinate, 0, comma, negative 6. The slope is telling you to go from there, from that dot, to find all the rest of the dots. You're going up 1 over 2, and it always goes to the right. That's just how I always think of it. So rise 1, run 2. There's your next dot. Rise 1, run 2. Rise 1, run 2. And I can graph that. And the reason why I'm allowed to make it a solid line is that you literally can use every number, including decimals. Okay, does that make sense? Not bad. It's one of the easiest go-to formulas. Now, from this formula, you can get to any of the other ones. I can get to general form, I can get to standard form, I can get to point slope form in theory. But I just want to make sure that you understand the concept of how this works, that idea. Okay. But no questions on that? I think it's like the go-to one when you have an equation graphed instantly. But let's talk about how do you take that and rearrange it? Because that's all it is. It's just purely rearranging this equation to get to the other forms, so that you know that. So let me get rid of all the slope stuff here. All right, so to take that equation and go to a different form, like let's say standard form. So I'm going to start with this: 1 equals half x minus 6. And I want to go, so that's in the slope-intercept form. I want to get this thing to standard form. Well, the number one thing is, do you even know what standard form is? What is it? Okay. X plus by equals c. That's standard form. Okay. Now, what are these numbers? Not for your problem, but what is a, b, and c? Think about it. What do those numbers have to be for this thing to work out? There's a certain stipulation. They have to be integers. They cannot be fractions. They cannot be decimals. So that's just something you need to realize. That's just a little quirky rule. Now, why we have this formula, why we have standard form, is because we use it for story problems. That's basically what it's used for. Somebody walked into a store, bought so many of these items, bought so many of these items, and this is how much they spent. That type of thing. And the x and y would represent maybe the prices of the items. That's the idea. That's what we use for Algebra 2. You go from a story problem to this form instantly. It's not the preferred method of graphing. Definitely not. If you're going to graph that thing, I would literally just rearrange it that way. So that's the easy way to go. That would be perfect. Or you find x and y intercepts. You plug in zeros and see what the other number is. That's that way. But definitely not the way to graph it. But to get this to look like that form, obviously the x and y have to be on the same side. That's what it looks like, right? The ax, by is on the left. The c is just a constant. It's just on the other side. So What's the first step to get that thing to look like that? Say it again? No, I'm already here. Get this to look like that. Yeah, move the X over first. If you're going the other way, yeah, graph theory. It's a y by itself, right? But if I'm starting with slope-intercept form and I want to go to standard, you're right. You got to bring this over with the y. You got to get them to the left side. So I'm going to do that first. What happens when I drag that half x over? It was negative. Not a big deal. I'll just put it out front. So it's negative half x plus the y. There's actually 1 in front of that, just so you know. And there's a negative 6 on the other side. Fine. But what was it really just said a little bit ago? What do my a, b, and c have to be? Integers. They cannot be fractions. So what we need to do is we need to get rid of the fractions. So if you have a bunch of fractions on this problem, and you need to get rid of all of them, just multiply by the common denominator. Well, there's only one fraction, so what's your denominator? Multiply everything by 2. Get rid of all the fractions. Now it's an easy problem to look at. So if I multiply everything by 2, multiply by 2, multiply by 2, multiply by 2. And that's the multiplicative property of equality. I can multiply the whole side by 2. The whole side by 2. So if I multiply this by 2, the 2's basically cancel. I'm left with negative 1x. Right? The trick is you take 2 times the top, which is negative 2, and divide by 2. That's negative 1. Right here, 2 times 1. That's 2y. And negative 6 times 2? Negative 12. This technically is standard form. Some books won't use the negative sign in the front. But if you want to get rid of the negative sign, just switch all the signs. Because you're multiplying everything by negative 1. So this could be a 1x, a negative 2y, and a 12. It doesn't make any difference. It's still the same form, however you want to write that. They're the same route. So how that would be like in a story problem. You went to the store, you bought 1 item, you returned 2 items, then you spent $12. That's it. So you're getting a certain cash back. So you're actually spending. Alright, any questions with like slope-intercept to standard? Doesn't matter which one you use, the one in the box versus the green one, they're the same problem. Okay, but now, the last form that we talked about yesterday, general. General form, if you don't know, is a lot like standard, actually. It's just this. And it's not, like, don't look at that problem, look at this problem. Like, it's just, this is its own form. That's just the letters they use in the book. Now, if you want to make this a different letter, like a D, that doesn't matter. It's just like that standard form. The X and Y are on the same side, that number is on the same side with A and B, and then there's a 0 on the right. This is what we do when we do, like, quadratic form. Like when you're going to factor things apart, algebra 2, right? You always want to get 0 on one side. You're doing general form, just so you know. So that's the idea. So the trick is all you do to get from this standard form to that one, just move the C over. So it becomes positive, negative, whatever. So like if we go to that problem right there. Now I'm at negative 1x plus 2y equals the negative 12. So how do I get this to look like that? What do I need to move? 12. So if you move the 12 over, it's actually negative 12. If it moves over, what happens to it? It becomes positive. Not a big deal. There's general. All right. Again? No, it doesn't. Not in those forms. They just have to be integers. They just can't be fractions. Most of the book prefers that they're positive. It doesn't have to be. So it's nice when it refers to it. Especially when you like factoring, you refer to positive. All right. Questions, comments. Do we see the differences in those? Okay, the last one is, for me, the last form, which is, we call it point slope form. That's the one I prefer. It's not just because it's the one you're supposed to learn in Algebra 2. It's actually the easiest one to, like, come up with. To start with random information. If you had a graph, and you had some data from that graph, you could go into this form, like, almost instantly, without having to put really any mental thought into it. And then from there, you can always get to the other forms. Like from here, I go to point slope, or I go to slope-intercept, and then I go to slope-intercept standard, and standard to general if I needed to. Like it's just one after another. But This is the one that I always find that most people are just, they've seen it. Like, you've seen it in Algebra 2, but you're just not comfortable with it. You need to see it like once or twice before you really get a handle on it, like how to use it. All right, so let's start with that one, and we're going to kind of work our way through here. Let's make that graph a little bit bigger so you can actually graph. All right, so give me two random coordinates. So 2, 6, and I heard a 4, but all right, so 2, 1, 2, 3, 4, 5, 6. All right, so there's 2, 6. 4, 0. Okay. And 1, 2, 3, 4, 0. Is that the number I heard? All right. So there's my two coordinates. Okay. Whatever this is, that's just random data from the graph. Maybe there's a line connecting them. It doesn't really matter. That we can go right away into slope or point slope form, which I'm going to put on the board here. We can go right into point slope form, and then from there we can get to the other form. After we're done with this problem, like me showing you it, I'm going to show you how you can go to the other form as well. Like how I can just bypass this one and go to slope-intercept, and how you go to like the other forms. But I prefer this one. This one I like. It's just so much easier than the others. Now, if you don't know it, this is the actual formula. It's y minus y1, m x minus x1. Like, that's the form. It's actually, if you don't recognize it, it is literally the slope formula, just written differently, just so you know that. If you look back at that formula that I had for slope, like that's a slope formula, right? What they did is they did a symmetric property by flipping it around. And they just multiplied both sides by the common denominator. So that's basically just slope. And you see how it is basically the same thing. It's just slope rearranged. That's why it's the preferred go-to. All right, so let's talk about how we can go to this one. Number one thing we got to do, we have to calculate slope first if you're going to use this. So slope is how far it's rising versus running. Now, if you look at that picture, what can you tell me right away? Definitely negative. Yeah, so it's definitely negative slope. You agree it's going down to the right. So whatever we come up with better be a negative slope. Okay, and you guys can like count with your fingers and figure out the slope from there. But so let's say we didn't like count with our fingers, like the slope is like going down, swinging over, swinging. This is how you calculate it, right? You take m, you subtract the y numbers from there. The y numbers are 6 and 0, so you subtract those. So I'm going top minus bottom. And then I'm still, for the x numbers, I'm going top minus bottom, so 2 minus 4. It is incredibly important you subtract the same direction. Don't flip-flop them just because you don't want to use negative numbers. So I chose on that picture top minus bottom, so 6 minus 0, that's the y numbers, and then I had to go top minus bottom, so 2 minus 4. So this turns out to be 6 over, what, negative 2? What does that simplify into? Negative 3, so negative 3. And so I'm going to plug that in. So far, we have a negative 3 for slope, or negative 3 for 1. Okay. We did it with the slope to begin with. How did I get negative 3 and everything? Okay. Now, for the rest of this, how I go to this formula like almost immediately, you just have to plug in a y1 and an x1 number. These are variables, but these are actually the numbers from the graph. So which coordinate do you like better? The 2, 6 or 4, 0? 4, 0. We're going to plug those in here. That's what we're doing. We're plugging in for x1 and y1. X number for the 4 was the 4, and so it's x minus 4. And then for the y1, we're going to plug in the 0 there, so y minus 0. That's it. That's your point slope form. You're done. If you wanted to go further and make it slope-intercept form, you just simplify it, right? So to simplify this, I would get rid of the 0. I don't even need the 0. And I would distribute the 3, the negative 3, I should say, through the parentheses. So negative 3x plus 12. And that'd be your problem. That's slope-intercept form. So that means in my graph, it's not going on scale, but it would hit at 12 here. That's why you don't want to use the graph like guesstimate where the y-intercept is. Like, just rearrange the equation and actually tells me. Okay, questions with that? How I can go to the other forms? Now from there I can make it the standard by moving that 3x over. I can make a general by moving 12 over and keep going. Okay, that's why I prefer this one. It's so easy to like just pick a coordinate, find the slope, plug it in, done. I mean, this is literally it. I mean, that's point slope form. Now, I know there's a way, especially in algebra, they like to teach you this this method of when you have a graph, can you go to slope-intercept right away? Not going to point slope, not this one, but going to this form. And I do want to show you that, because I don't want to hide that from you, because there is a process for doing that. It's kind of some elegant math you can do there to actually get that equation right away from the graph. The first thing, you do slope like normal. So we did slope earlier, what was my slope? -3. You can plug that in right away, right? -3, that's my n number, right? To find the b number without guesstimating from the picture, because my picture was terrible, right? It's supposed to hit 12, but it looks like it's going to hit like -10 or positive 10. So to figure it out, what you do to go to that form, you just pick one of these coordinates and you plug it in. So give me one of these coordinates. Pick one. 2, 6. All right, we're going to do 2, 6. And you plug it in here. So I'm going to plug in the 2, 6 into this problem. Notice where I'm plugging in. I'm plugging the 2, 6, that was the coordinate you just picked. I'm plugging the 2 into the x number, 6 into the y number. And so this turns out to be a -6 here, that's a b, and this is 6 on this side. And then all I need to do is solve for b. So if I solve, I'm going to move the 6 over. What happens when I move the 6 over? Positive 6. So it looks like my b number turns out to be 12. And now that's like my final equation. I can plug that 12 back in. So if I plug the 12 back in up here, this is the answer. Which is the same thing we came up with earlier. That's why I think this is so much easier. It's like one step versus, what is that, 5? Took me to get there? Some people can do it with their head. But does that make sense, like how I did it? I didn't want to hide that from you. Like, I want you to see that. It's like the way that they definitely cut you in algebra. Hopefully. So. Okay. Questions, comments, concerns on any of the different forms, like their uses. Why do you ever use this one? You go from data right to a formula that I can use. I can project. I can use this formula to project what will happen later. So now I'm like, oh, what will the sales be at the first month? Well, I can plug in 1 in my x and I can figure out what the sales projections are. Because now I have this formula that I can use to actually guesstimate what the next numbers are. Okay, so let's talk about a review here, because I think we covered everything. This is the new one. I didn't know if you went too in depth on that one. But I want to do a quick review. Are you comfortable with this? That's what I want to talk about. So let me pop up the problem here. Does anyone need this? Okay, so we're going to try like 4-prong review. That's all I want to do. 4 prongs. Okay, so here's your first one. Your first review problem. I want to see if you can attempt on your paper right now. See if you're kind of quasi-ready. Okay, point slope form, the equation that has this information. Now, I didn't give you graphics. So I gave you a coordinate, I gave you slope, right in point slope, and then I want you to rearrange it to slope-intercept.
On test day, do you have all the slope equations on the board?
Yes.
With labels?
No. They'll be on there. Just won't wait. Let's see if you can do this. So use your notes, figure it out, put it in your notebook paper. I want to see how well you do. And we'll discuss it. Remember, you want to start with point slope form and then just rearrange it.
Just rearrange it? I'm not.
You're killing me.
Kill me, small, kill me.
So hard. Oh, you are First Wednesday of the month.
Wait, is that next month or next
Oh,
week?
hard
Same
pass.
thing.
Guess
Hard
what?
pass.
Yeah, you're probably not gonna be the regular leader. No.
Tyler's later too, he's not even gonna be there.
You sing
I'm
for
the
the radio?
leader. I actually go.
Sir,
That's a good point.
I've gone Sundays.
No, you got to work.
They have that sign.
And I was late to the bonfire,
And
so.
it was your idea.
No, I was Rebecca.
That's just said it was your idea.
No.
I think it was Karen. You always do. I got worse than that. I don't know.
All right. Hey, so I know some of you are like, you got the process started, but I noticed the last number was the one that was off. Everything was kind of, the setup was correct. Now, what you should note here, this is where we're starting. We're starting that slope, or the point slope form, that's that one. And we're trying to get to that one in the end. So the start should be super easy. I give you a coordinate and I give you slope. So that, right now, that's point slope all the way. I mean, it's super fast to plug that in. Because what's my slope on this problem? -3. So I already have like a majority of the setup correct. Now all I need to do is plug in the one coordinate that they gave me. They gave me the -1, 5. The 5 is the y number. The -1 is the x number. So what happens here, this turns out to be positive, right? So it's negative. So this should be your point slope. That should be your setup. Like most people do that like the first step they see the problem. That's great. That's like what you should start with. The problem is you need to rearrange because it said it wanted slope-intercept form. So that means to get slope-intercept form, I need to get the y by itself. So that means I need to get rid of that -5. And I need to make sure that there's no parentheses anymore. So I need to like distribute. So distributing the -3, that's where some people went wrong. So I'll get rid of this 5 here in a second. So I'm going to distribute the -3 to both, and what do I get? -3x minus 3. So you have to distribute the negative sign with -3. Yeah, and then what you'll do next is actually add the 5 across. So this 5 needs to go over because I need to make it look like that. That's kind of the goal. So I'm gonna, that -3x will be left alone, but I'm adding the 5 across, and what is -3 plus 5? 2. Alright, so y equals -3x plus 2. Okay, the most common mistake that I saw was the 2 in the back. A lot of people put 6. The reason why? They forgot to distribute the -3. You know, they forgot to put the -3 on the 1 in the back, so they didn't have a -3 statement. Okay, that was a common mistake that I saw. The other mistake that I saw, just one mistake, something you forgot to have a plus here. Just the 2 negatives at the end. The negative. Okay, questions on that problem? I know that was brand new to us. I mean, we have not seen point slope form, so that's why I wanted to show you that. How can you start and move on without looking at a graph? Okay, let's try a different one. Let's try a second one. Because now that you guys got the concept down. Okay. All right. I want you to write, just do the top one. Just do the top one. Don't do this bottom one. Just do the top. I want the equation in point slope form through that thing. That's That's all I want, just one. Let's just do the top. You don't need to go to the slope-intercept or anything like that. Number one thing I can tell you, be careful on what your slope is. Be very careful on that.
Today's Friday.
Now, hey, here's the thing. I know some of you are like working on this, and you looked at your neighbors, you're like, whoa, I didn't get the same answer as my neighbor. Here's the thing. Your slope should be the same for sure. But what if your neighbor picked a different coordinate than you? Because there is two coordinates on the board. They could pick either of the two to plug it back in. Okay, the first step, we got to find slope. How do you find slope? Yeah, changing y's. These are your y numbers. You had to subtract those. I don't care the order you do it. I'm going to go front minus back. So that's going to be, so on my slope, it's 2 minus the negative 4. So that's literally 2 plus 4. Okay, that's the top. That's your y numbers. The x numbers is 4 and the negative 2. So 4 minus the negative 2. So that's 4 plus 2 again. Now, if you went the other way, you went back minus front, the same, you get negative numbers on the top and bottom. Because what happens here? Yeah, they cancel and make 1. That's your slope. Easy. Slope is 1. So now I can go to point slope form, which is that one on the board, and I know my start. My slope is 1. All I need to do now is pick a coordinate to plug in for x1 and y1. So what coordinate do you like? Okay, you want to use the second. Okay, so we're going to use the second coordinate now. That's the one that you picked. So we're going to plug that one in. And it makes no difference. It's the same formula. So I'm going to plug the negative 2 and the negative 4 into this thing right here. So if I plug it in, I'm plugging in the negative 4 for the y number. I'm plugging in the negative 2 for the x number. Because that's the coordinate we picked, x and 1. We have to subtract them. So this is what it simplifies into, if this is the one that you picked. Now, if you didn't pick that one, let's say you picked the front coordinate. The front coordinate would just have this slightly different result other than this. This will be a minus 4, and that will be a minus 2. That's the only difference for those. Because it depends on what your x and y number were if you're subtracting. Okay, do we see how we get slope, though? Slope is important that you subtract the right numbers in the right order. So the y numbers versus x numbers. Okay, here's your homework today. Pretty straightforward. I'm going to hand you some graph here. paper. It's going to be due on Tuesday this week. And then I'm going to get your practice guide as well. And I'll have Miss
Or you mean Tuesday next week, right?
Tuesday next.
Okay, because he said Tuesday this week.
No, Tuesday next. Okay, so here's your homework. You'll need graph paper, so I'll hand that out here in a second as well. All right,
Next week
page
is
188. 2 through 6 evens. 8 through 10. 14, 15. These problems are basically look at a picture, tell me what slope is. Is it going up? Is it going down? Is it horizontal? Is it vertical? That so all it is slope. 19 through 23 odds. 29, 30, 35, 37. These problems, they're going to have you take information and put it in like point slope form or slope-intercept form. Those problems. They're watch on the setup. They're going to give you different things each time. Point slope form would be probably the preferred method for most of these, but then you have to rearrange it. And the last few, they're going to have you graph. And so that's why I'm going to have to give you some graph paper here. So you're going to graph those, I think. 6, 40, 42, 44, 46, 48. So Abrams. Yeah, that's correct. Okay, now some graph paper here.
Are we starting at 40? Is that what we're dropping 40?
Yeah, it's those. Because it's only on those you're going to have to graph. The rest of them just...
Yeah, I get it, but I'm going to need two also.
On the seat, and I didn't lock the door open. I didn't even think that there's a note right there. I didn't lock the door open and down.
I'm not going to be here.
Like, half this one.
You know what, I said we just start the old decon for a little bit.
Okay.
Rebecca wanted to on if I can, I'm like,
But then you get to like here, and it's like,
I don't use the
Hey, just a reminder, when's our test in here?
that's Bailey's.
Thursday next week. That means we have one more section that we're going to go over. We're going to start that Monday, and it's not bad. It's basically just equations like this. We're not anything crazy new. We're going to talk about parallel and perpendicular. On Tuesday, Wednesday next week, we'll start reviewing. That's what we're doing. We're reviewing for that test. So the practice guide will be your best friend on those. Okay?
Wait, what are we doing Monday?
Monday is the next section, 1-5, which is basically the same concept, so that's why it's kind of nice that we've done this. But Tuesday, Wednesday we're reviewing, and then Thursday is your test in here. You have the practice guide in front of you. That is due on Thursday when we take that test, so that you know it. Okay? Weekends, quarter 2 grades will be updated with the homework you turned in.
Jack.
I like my pencil bag in my ear, and I have like that.
Oh, I think I'm Durger. I'm headed up to Walmart real quick before I go to Brighton.
I have to write. I said, I have to read tomorrow at 5.
Maybe you're right.
And then I sent them, I in the morning.
You made me sad, so I wanted everybody to feel the pain at that moment.
John Neal, please come to the office. John Neal.